Thank you, sir. So, good evening. Today, I, Rupali, on behalf of my teammates, Syed Uzair Yajat Vashisht and Vipulesh Vashishth, under the guidance of Dr. Sudhir-Chaturvedi, presenting my topic on inertia measurement unit, INS, with the detailed diagram and explanation. So, one second, it's not. So there are 5 basic forms of navigation system. The first is pilotage system, which essentially relies on recognizing landmarks to know where you are, and it is one of the oldest method of navigation. Second is dead reckoning method, which relies on knowing where you started from uh, plus some form of heading information and some estimate of speed. Third is celestial navigation system. Using time and the angle between local vertical and non-celestial objects, we use the celestial navigation system. Fourth is radio navigation system, which relies on radio frequency sources with known location, including GNSS satellites, Lorentz, Omega Taken, and US Army position location and reporting system. The fifth one is the inertial navigation system, which relies on knowing your initial position, velocity, and attitude, and thereafter measuring your attitude rates and acceleration. The operation of inertial navigation system depends upon Newton's law of classical mechanics. It is the only form of navigation system that does not rely on the external references. These forms of navigation can be used combined in the combination as well. The subject of today's presentation is fifth form of navigation, that is the inertial navigation system. So the word inertial comes from the inertia, is the properties of body to maintain constant translation and rotational velocity under disturbed unless disturbed by the forces or the torque. And the inertial word comes from the from inertial reference frame, which uses Newton's law of motion, and here the inertial reference frame are neither rotating nor accelerating. The sensor used in this inertial navigation system are the inertial sensors. An inertial navigation system is a self-contained device consisting of inertial measurement unit and computational unit. So the main components are IMU and computational unit. The IMU is typically made up of 3-axis accelerometer, 3-axis gyroscope, and sometimes 3-axis magnetometer, and measures the system's angular rate and acceleration. The computational unit used to determine the attitude, position, and velocity of the system based on the raw measurement from the IMU given in an initial starting position and attitude. So the INS uses 2 basic types of sensor. One is gyroscope and another is accelerometer. The gyroscope is a device which which used to measure the acceleration and measure the rotational rate. So it basically depends upon the 2 basic principle. One is the rigidity and precision. So imagine a top on a ground. If we simply put a top on a ground, it falls down. But when we give it motion, it starts rotating on its axis. This property is known as rigidity. And second property of gyroscope is precision. To understand precision, let's imagine if we give a force it to resist change. Imagine there is a wheel, and if we give force to it, it will resist the change of the plane. So the force we are providing shifts 90 degree. the second sensor we used is accelerometer. However, cannot measure the gravitational acceleration. There are many different types of INS with different performance characteristics, but they fall generally into two categories. One is gimbaled or stabilized platform techniques, and second one is strap down. A gimbal is a rigid with a rotation bearing for isolating the inside of the frame from the external rotation by bearing axis. At least 3 gimbals are required to isolate subsystem from the vehicle rotation about 3 axes, typically labeled roll, pitch, and yaw axis. The gimbal in INS are mounted inside one another, and gimbals and torque servos are used to null out the rotation of stable platforms on which inertial sensors are mounted. Another is strap-down inertial navigation system. In this, accelerometer is mounted on the airframes and measure the acceleration of the body. The horizontal and vertical acceleration is computed analytically using the direction cosine matrix relating and the local level of navigation system. The DCM computed using strap-down body mounted gyro outputs. So the advantages of the this strap-down inertial system is it autonomous and does not rely on any external aids or visibility condition. It can operate in a tunnels or underwater as well as anywhere else. It is inherently well suited for integrated navigation, guidance, and control the host vehicle. Its IMU measures the derivatives of the variables to be controlled. It is immune to jamming and inherently stealthy. The disadvantages include the cost. The execution operational cost and maintenance cost is very high, and but the size and weight is shrinking, so we prefer to use it. Another disadvantage is power requirement, which have been shrinking along with the size and weight, but still is higher than those of the GPS receivers. And other is heat dissipation, which is proportional to the shrinking with the power in requirement. Thank you.